Hello and welcome. So today we will discuss a data structure named tree, right? So tree is an abstract data structure and it is basically used to form a hierarchy. So very basic example of tree is the way we see in our folder structure, right? In one folder there are different folders, right? So in one parent folder there are different folders and after that there are different folders. Say if I create a tree, so it will look something like this. One node, then there will be another node connected to it, and then another node, and there are different nodes actually, right? And actually it is an application of doubly linked list in I have already told about the linked list. So actually how it is being stored in the system is something like this. We have some data structure like this: a, right, and it is having link to other part, right, b, and it is having link to its other part, something like this, and b is having address of its parts, right, and then it is having link to another node, right, and means usually we, for simplicity, we draw it like this, but actually in programming it is being created like this, right? And these are like, this is a node which is having left child and right child. So what are childs of a tree? This is called, first node is called root node of a tree. This is root of a tree, right? And then left side is called left child, right side is called right child, right? And if we move on till the last node of the tree where no childs are being, these nodes are called leaf nodes. Leaf nodes. So what are the leaf nodes? D, E, F, G are leaf nodes. Nodes where no further children are present, right? And these are internal nodes. These are internal nodes. B, C, and A are internal nodes. These are internal nodes, these are leaf nodes, this is root, right? So now while creating a data structure like this, it is having one part as data and two part as link, right? So one part as data, I'll just zoom it out. So one part is at data, this is data part, and this is link part. These two parts are link actually. These are link parts. Link part means both of them are linking to some same data structure. So if we create a node in a tree, so how we will create, right? I will declare a structure. I will simply write a structure struct. So I am writing bt node, binary tree node, right? If it is having two children, then we say it as binary, right? Binary tree node. So we are just starting, we will deep dive into it. bt node. Now it is having one part as data. So say I am storing some integer, so I will write int data part. So if you have seen my linked list video, you will get through this very easily. Int data part. Now there is left child and right child, right? And left child and right child is also of type bt node type. So I will write struct bt node type pointer only, left child pointer, and struct bt node type pointer, right child pointer, right? So this is how you construct a structure. Means this thing will give you a node of a tree, right? So how it will be like filled, how the values will be filled in the tree? that we'll see now, right? So say this thing, this data part, right, and left and right child. So how this is being filled, that I will show you. Say this node is having address as 1000, this left child is having address as 2000, right child is having address as 3000. So I will remove all the links. This is like some independent nodes you have created, and then this is having address at 400, 500. For simplicity sake, I am writing the addresses like this: 600, or say 9000, right? So how, with this structure, you can create the binary tree node, right? You have created several nodes, so how you will link them, right? That's what I'm trying to say. So when you want to link this B to left child, so what you will simply do, you will write 2000 here, and this will point to this memory location. You will simply write in this part, you will simply write 3000, and this will point to right child memory location. In 2000 left, you simply write 400, it will point to this D node. Right, you write 500, it will point to this location. In it, this C node left, you write 600, it will point to this location. And in this node, you point by writing 9000. So this is how our tree is being constructed. And leaf node will contain null. Actually, I am kept writing with capital N. This is null, right? So leaf node, there is another property. While coding, we will take care of this property as whatever node which is having left and right child itself as null, right? Left child and right child itself as null, that is called as leaf node of a tree, right? So this is how your basic tree is being constructed. So after creation of a tree, say we want to read a tree. How we read a tree? So there are different type of aspects. For simplicity, I am making it like this, right? So we'll check in how many ways we can read. We can simply read. First we can read root, then we can read left child, right? And then we can read right child, right? So left is called left child, right child, right? Then another thing can be, first we can read left child, then root, and then right child, right? Then there is another way, we can read childs first, right? So left child, right child, right, R child, right, what I am saying, right child, right, root, right child, and then left child, right child, and root, right? So these are different ways, right? So how we have permuted is it with respect of root only, right? You see, if root is in front, right, we first read root, then left child and right child, then we call it as pre-order. We are reading tree in the pre-order way, right? If we read tree like left child, root, and right child, means root is inside with left and right, then we call it as in order, right? And if we read a tree with left child, right child, and root, then we call as post order, right? And I will simply write pre-order, post-order of these values as root is A, left child is B, and right child is C. So this is pre-order for this tree. For this tree, left child is B, root is A, right child is C. This is in order. Then B, C, A is post order of this tree. So why we are discussing it? Because this used to come in lot of exams. What is the pre-order? What is the post order? What is the in order? Right? In fact, this can be achieved with the help of recursion itself. So first we will understand the concept, then we will try to write the code, right?